where I go out to schools and do science shows in a hopefully fun and interactive way, and I've brought some of my experiments with me today. So we're going to start off with this little baby here because somebody was very curious about what this is about. And when I'm going to say this is a student testing device. This is a student testing device. Because I test if students can focus, if they can concentrate. Right. So if you can concentrate, you are actually able to bring the straw. Everybody can see the straw inside here. Everybody can see the straw inside here. You can actually bring the straw and make it sink to the bottom. But you have to concentrate.
What?
You have to concentrate. Guys, I'm going to leave this here. Okay, all right. So, everybody's focused. Okay, we're gonna split the groups in half. So the young bucks versus the old bucks. Okay, right. Okay, and I'm glad, sir, that you were in the middle of the young bucks. Yeah, very well positioned. Very well positioned. Okay, so you're concentrating. We're concentrating on 3, 2, 1, and. I said concentrate. We are. Concentrate. Okay, maybe the old bucks, they can do it. Right? Okay, let me just go to this side here. Ladies and gentlemen, you concentrate very hard. In 3, 2, 1, and... Okay, 2, 1, and... Okay, so this is one of the most simplest experiments that you can do in class, okay, to engage learners and talk about a simple thing called pressure and about the compressibility of air. Because what do we have? We have a straw, and inside the straw there is air inside. Okay? So of course you weren't thinking of it. What I just simply did, I was squeezing the bottle. I saw you. When you're doing experiments, of course you could have just said, oh, okay, so here's a straw, now squeeze, and end of story. Okay, but you want to bring a little bit of excitement into the classroom. So this is one of the things of how you can do this. So how does it work? So inside here again we have some air, so you can talk about compressing. That air is actually compressible, so that you're basically pushing the water inside, compressing the air bubble. Water goes up, changing the density. This thing sinks to the bottom. If you release it, what's happening with the air bubble? It expands and it goes back up again. Okay, so we actually find this in not everyday life, but submarines use the same principle. So you have compressed, so you basically flood the compartments with salt water. The submarine sinks. You push the water out with compressed air. The submarine starts rising again. Okay, so very simple to make. It's just a straw taped on top, and then you just need to put weights so that it's just barely floating in the water. Right, next one. I'm actually thirsty. Hey, I'm thirsty. Okay, you can try it out. You can squeeze. Oh, see. So, a challenge. A challenge. Can I turn this glass upside down without the water from coming out?
Yeah. Obvious, yes.
How would you do that?
No.
Wait. Try it out. Yes.
So can I flip the glass without spilling the water?
That is the question. Can you?
Yes, no. Yes, you can, but put it palm.
There's somebody who comes up with a solution. Yes, we can, if I would put my palm up. I've got something way better. So I usually tell people, okay, do you like ice cream?
No.
Yes, everybody likes ice cream, right? So, any special flavors? Vanilla or chocolate, you know. This is I said, you know, what you're going to do is you're going to go to a shop, ask your parents when you're working with kids, you know, to buy you a big tub of ice cream, right? And then what you're going to do is you eat the ice cream and you keep the lid. Okay, you can also do this with the margarine lid, but you know, of course, margarine doesn't taste as nice as ice cream. Okay, right, so you were saying this was a suggestion. So what you're going to do is you're going to place it on top. And then what you're going to do with it? And I'm going to say, oh, here we go, you see. Now my question is, can I take away the head?
Yes, you can. If you focus on the class, you can.
I can. If I focus on the glass, would you do that for me, sir? Would you? No. I'm gonna focus on the glass, and you're gonna stand on the head.
Oh, never remove. Don't remove that thing. Focus on the class only. Then you can remove.
Okay, so maybe we try this out. Do we have a volunteer who's gonna think that this is not volunteer here? Okay, we'll try it out. And 3, 2. No. 1.5. 1, and you can actually. Okay. Again, pressure, but also a very important property of water, which is called surface tension. So if you just use pressure and you don't have water in it, the lid would just fall off. So what happens is that the water basically acts as a seal around it. So this is quite important. And this is also, you can talk about surface tension, you can talk about pressure difference, so that your air pressure not only works from the top, but it works from all sides as well. Okay. But of course, what you should not do is this, right? Okay. Right, so, yes.
Can it be any wood? Or it has to be polystyrene material like that?
No, it can be any type of glass, so you can also do it with a plastic glass, okay? I wouldn't use any fizzy drinks because the carbonate does maybe funny things with it. You can try it out, but I wouldn't try it. And I also wouldn't use wine because it stains when it goes wrong. And believe me, it will go wrong when you use it. Okay, so scientists like to do modification. So here we've got a nice little dressing here, you know, like a mini skirt. Okay. So, and what we're going to do is we're going to just add water onto it. Right, and now we do the same experiment again. So I'm going to put the lid on. And I'm going to turn it upside down. So, what do you think what's now going to happen when I take away the hand?
Water will just leave.
So who thinks the water will the water will come out?
You won't come out.
You won't come.
It's
We
weird.
just found ourselves a volunteer. Give him a round of applause. You can just come here. Just come here. Okay, no. Go down, bend down like this. Okay? So you water's not going to come out.
I said it will come out.
Okay, so I hope that you notice is that you can do science by engaging your audience, and this is especially when you want to teach young learners about science, that you have to engage them. Right, so you can take them out, get them up to the front, and so on. You can let them do the experiment. Oh yeah, now I scared him. Eh? Any volunteers here so that we can take it off? Okay, so we'll try this out in 3, 2, 1, and oh, luckily. But you know, if I would have done this, the water still wouldn't move.
How?
Can I touch it?
How?
So again, a very simple experiment that does not cost the world, and the reason why the water didn't come out is also because of the surface tension. I'm just going to do this. Okay, so when you look at the net here, you can see that the water is basically clinging to the pores of the net. Okay? So it's clinging to the pores of the net. So it forms a very thin, fragile barrier, but it's still strong enough to keep the water inside. When you do this experiment, please do not pull it down like this, because then you're in big trouble. Okay? You always slide it sideways. Okay, very carefully, slide it sideways. Right, okay. Okay, so I love the internet, okay? And what I usually do is I Google, and I came across this fantastic website. And on this fantastic website, I found this self-inflating balloon. Oh, I said, yes, this is what I need, self-inflating balloon. Can you imagine, it's my birthday, you have to sit there and like, no, you don't. Okay, so I bought this one. Here it is, 100 rand. Oh. Okay, I thought, I'm always up for gadgets, so I bought this one. I should mention it comes from a Chinese web shop. Yeesh. Have you ever read the instructions? Pull thing over push. So I figured out that it has. I had to put something into a bottle like this, okay? And then I'm going to demonstrate it to you now. And then I'm supposed to put this one over. So, and we're going to do this in 3, 2, 1, and over. Hang on. Yes, here we go. Doesn't work. Yeah. Any ideas why? Yeah, I know you know. You can help just now. Any ideas? Well, what can we do to make it inflate? Yes, it does. Well, it's a little bit disappointing. Right? It's not really like super duper big. Okay, so you have a suggestion.
Unfortunately,
Yeah,
it's gonna be the same.
you are okay. All right. So maybe you can still help me. Let's come here. Okay. Yes. Exactly.
Yeah,
So what you're gonna do is you just lift up the balloon. Hold it up, like this.
Yeah, what's that now?
The self-inflated balloon. Give him a round of applause. Again, a very simple experiment, just using vinegar and bicarbonate. And you can talk about, okay, so here we have actually a chemical reaction. We have a gas. And this is what basically we find inside the balloon. Okay? So the gas is inside the balloon. And we can see the bubbles, and you can talk about the bubbles. You can talk about, what kind of gas do you actually find inside, and so on. Okay, because of time, I think. Because of time, okay. Just one last one. What is going to happen if we do the same experiment, but we are just doing it in a very confined space? What do you think what's going to happen?
The results will remain the same.
Okay, so you say the thing. Okay, so remember, this is the amount of. Yeah, but now we're gonna have it in here.